Oh, I forgot to list this up here. All right, we're going to go on to our next set of notes. This is going to be notes number 4, talking about the atmosphere. Now, yesterday I introduced to you what the atmosphere is. I'm trying to find the present button here. And how the atmosphere is kind of like a almost like this invisible layer of air, kind of just like a bubble around the globe, around the earth. So today we're going to talk about the different layers within the atmosphere and the characteristics of each of those. So just as a review and to give us a scientific definition of what the atmosphere is the mixture of gases that surround the earth. The atmosphere extends from Earth's surface to more than 600 kilometers into space. So I mentioned this yesterday, but what this means is if we were to start at the surface of the Earth and then go out, it would take 600 kilometers for us to go through the entire thing before we enter into space. Okay, it does get thinner. That's why you can see it gets, let's bring up my pointer here. I want y'all to be able to see what I'm talking about. Okay, as you can see here, it gets thinner as you go out from the Earth. The closer you are to the surface of the Earth, the thicker the atmosphere is, the more air there is. But the further away you are, the thinner it gets. So it would take 600 kilometers going out before you finish getting through the whole thing. It lies between Earth's surface and the vastness of space. I clicked the button, it does nothing. Okay. I didn't skip any, right? It is described as several layers with different temperatures and densities. So that's what I was explaining earlier. Over here in the picture, you can see that the layer closest to the Earth looks white, and then it gets a little bit more clear until you can see the blue behind it as you go out. That's just showing you that the atmosphere does get thinner, and there is less air the more you move away out towards space. I forgot my drawing was right there. The layer boundaries may change with the seasons. So in certain seasons of the year, depending on whether it's warmer or colder, certain layers may be thicker or thinner, just depending on the weather outside. And this is a physical characteristic of the Earth. Okay, one of the ways we distinguish or separate Earth from all the other planets in the solar system is that Earth has its own atmosphere. It has this bubble or this layer of air that surrounds it. Not every planet does, but Earth's atmosphere is very particular. It's not the only planet that has an atmosphere, but it is the only planet that has an atmosphere like the one that we have, that is suitable for us to live on. Okay, so we're going to briefly talk about each of the layers and the characteristics. There are 5 layers, okay? And depending on which scientist you talk to or who your teacher is or what book you're reading, they may combine 2 layers, they may add an extra layer on the outside. It just depends, but these are the 5, generally the 5 main ones. Okay, you can see here, let me get my focus little thingy again. All right, so this green section would be the surface of the Earth. The first layer of the atmosphere outside of the Earth is what we call the troposphere, okay? And according to this picture, it goes from 0 miles up to 8 miles. So again, if you were in a rocket ship, you would need to travel straight up for about 8 miles before exiting that layer. The second layer is about 8 to 30 miles. That's the stratosphere. Then we have the mesosphere and the thermosphere. Okay, now in our notes, we're actually going to add one more layer on the outside called the exosphere, which I believe I have in some of the pictures coming up. But like I said, it just depends on what source you're using. They may or may not have all of the layers that you see here, but generally they're going to have something very similar. And in reference to this, I like this picture because it puts the measurements in terms of miles, which we're a little more familiar with. However, I don't think they're as accurate. But anyway, this is the correct order of the layers. Okay, here's another picture. We have the troposphere, which this one actually shows you some of the characteristics that we're going to get to in our notes in a minute. But this is the troposphere, then the stratosphere, the mesosphere, the thermosphere, and the exosphere. The easiest way to remember the exosphere is this is the last layer of the atmosphere before you actually exit into space. Okay, and then just one more diagram here. The first layer, again, is the troposphere. Then we have the stratosphere, mesosphere, and thermosphere. Okay. Now, in the notes section, I haven't been talking about the different characteristics of the layers yet because I want to get to them in the notes. So we'll talk about those more specifically here in just a minute. Okay, so characteristics of the first layer. This is called the troposphere. Okay, so in your notes where it says the layer of the atmosphere closest to Earth's surface is called the blank, you're going to write troposphere, just like you see here on the slide. Okay, this is the troposphere, and it extends from Earth's surface up to about anywhere from 9 to 20 kilometers, depending on the seasons. It may be a little bit further or closer. This is where we find 80% of Earth's air in the troposphere, which is a really good thing because we live here, right? We need to have that air here, otherwise we won't be able to survive. So this is the most dense layer of the atmosphere. It is closest to Earth's surface, and therefore the most amount of air is in this layer. This is also where most of Earth's weather happens. So rainstorms, tornadoes, hurricanes, sunny, windy, cloudy, hail, all of the above, all of that will happen in the troposphere. The temperature in the troposphere is an average of about 25 degrees Celsius, which is averages out to about 77 degrees Fahrenheit. Again, just in case you aren't aware of this, but we do use the Fahrenheit temperature system. However, the rest of the world uses the Celsius, and including the science world. So most of science temperatures are measured in Celsius degrees. That's the capital C that you are looking at here. But in America, we're more used to Fahrenheit degrees. So this would be about 77 degrees Fahrenheit. So this is going to be about your average warm/cool day. It's not super cold, not super hot. The troposphere is the one place in the entire solar system. So of all the planets that orbit our sun, this is the only place in the whole system where the temperature is just right to support many kinds of life. This is why, up until this time, we haven't been able to find significant proof of life on any other planet. Okay, Mars doesn't have any, Jupiter doesn't have any, Neptune, Uranus, Mercury, Venus, any of those. None of them have actual proof of living things there. And that's because they need to have, in order for living things that, like what we know of, to survive, there has to be air to breathe. And the temperatures have to be suitable for human beings and animals and plants and bacteria to function. So in the troposphere, lots of things happen. This is where clouds form, winds blow, planes fly, storms happen, weather balloons pass through, and people make direct observations. So this last part here, people make direct observations, just means you can look outside and see something and say, wow, it's a cloudy day, or wow, it's a sunny day. That would be you observing something directly with your eyes. So troposphere is what we're most familiar with. It's where we hang out. Okay. In your notes, that last bullet point, you see in the troposphere, and you see those two long lines. You do need to fill in the rest of what I have here. Okay. Anything on the screen that's not in your notes, you do need to write in your notes unless I've otherwise said so. All right. So this picture I like because it shows you the different layers as well as the characteristics. Let me see. If I move the mouse, you guys are gonna. I'm afraid it's going to block it with the menu down here, but that's okay. So here we have the troposphere, okay? Another interesting feature with this picture is it shows you the height of Mount Everest. It's over there to the left of the word troposphere. So even the tallest mountain that we know of on planet Earth is not even tall enough to break through the troposphere, okay? So you see the clouds form there. This is where land is, all the people are, etc. But over on the left column, it says this scale shows how the thickness of the layers compares with each other. So if you look down at the very, very bottom there, you can see there's just a tiny little bit of blue, that really light blue strip at the bottom. That's how thick the troposphere is in comparison to all the others, okay? And don't forget, Mount Everest can fit inside of that little layer. So while to us, in our perspective, it seems like a very big layer, if obviously Mount Everest can fit in there. It is still, by a long shot, it is the smallest or skinniest layer, even though it has the most air packed in there. Okay. Next, we have the stratosphere. This is the last bullet point on the bottom page of your notes. It says the layer above the troposphere is called the stratosphere. The ozone layer, which if you've heard any kind of news articles talking about global warming or anyone talking about hazardous like car exhaust and emissions and chemicals that are harming our environment, most of the time I'm talking about the breakdown of the ozone layer. Okay. The ozone layer is important because it helps, it protects some of the radiation from the sun from getting down to the surface of the earth, which really helps protect our planet quite a bit. So that's why people are so concerned about it breaking down. But if you ask me, honestly, not a whole lot of, I haven't seen a whole lot of proof yet that it is actually a problem. So anyway, this is where the ozone layer is. And the other characteristic of the stratosphere is that most of the jets fly here. In the stratosphere, we have something called the jet stream. Okay. You don't see it in this picture, but we're going to put it on our diagram that we will do on Monday. But the jet stream is like almost like a draft of wind that kind of blows through one of the layers of the atmosphere. And it's kind of like a turbo boost in a way. So sometimes when planes are flying from one location to the other, they'll try to get into the stratosphere because those are really strong winds that will carry them and they don't have to use so much gas. So that the jet stream is in the stratosphere. This is also where we send weather balloons like you see over here. Okay. A weather balloon is a tool of observation that meteorologists will send into the atmosphere in order to gather data to send back to them on the earth so that they can then predict what kind of weather is coming. Okay, they can see the temperatures, the humidity levels, the moisture, if there's any incoming storms. That's what they would use to make predictions about what the weather will be like in the next coming days. Okay, so the weather balloon is where it kind of hangs out in the stratosphere, as well as the ozone layer and the jet stream. Let me go ahead and clear my screen here, and then we'll move on. All right. Next, we have the mesosphere. This is the third layer. You should be on the back page of your notes now. The mesosphere is just above the stratosphere. And this is a layer where there's not a whole lot of air. Things start getting really, really thin up in the mesosphere, which is why planes don't typically want to fly much higher than that because there's no oxygen. There's no really way for you to breathe up there. However, even though there's not a lot, there is enough air to create the friction that I was talking about yesterday with when you rub your hands together like this and they get really warm. That's because you're creating friction. That energy is called friction, two objects rubbing against each other. With meteors, when meteors or rockets or not rockets, rocks or objects try to enter into the atmosphere, remember I mentioned how they're zooming through all of that material, and as they get pulled and sucked in by gravity closer and closer, they move faster and faster. Well, the faster they move, the faster they're rubbing up against that air, the more friction and temperature they're creating until they eventually burn up altogether. Okay, so the layer where these rocks burn up and create what we call shooting stars is the mesosphere. Okay, so even though there's not a lot of air here, there is enough air to create the friction needed to burn up meteors, and so those are what we see as shooting stars, those burning meteors. Okay, radio waves are also reflected to Earth in this layer. So in the picture you can see right up here. I don't know if you guys can see my little mouse. Let me circle it. Okay. We see some meteors. They actually burn up usually before they finish coming. So as this will be like, okay, rock enters the Earth's atmosphere, is coming, creating friction. Now it's gotten so hot that it's actually burning up. Okay. And that's what that burning is what we see as a shooting star, or sometimes we call a falling star. Okay. So that's the third layer. So we got troposphere, stratosphere, mesosphere. Next, we have the thermosphere. Okay. You've probably studied this before in your Greek and Latin roots if you've been at Founders for any length of time, or if you've just studied Latin or Greek and Latin roots at any point in time. But the root word therm, okay, is the same root word that we use for thermometer, measuring the heat of something. Okay, so it makes sense that the thermosphere is the hottest layer of the atmosphere. That's why we call it the thermosphere. The thermosphere is the fourth layer. This is the next one. As we go out, so we got troposphere, stratosphere, mesosphere, thermosphere. There's not a whole lot of air in thermosphere. Remember, the more you go out from the surface of the Earth, the less air there is. And it is extremely, extremely hot. Okay. The thermosphere is where the aurora borealis is, okay? Aurora borealis is the Latin term for the northern lights. The northern lights are what you see in this picture right here. They're more commonly seen at, I believe, super North Pole and super South Pole, I want to say. But it has to do with the way the light rays are interacting with the atmosphere. They kind of bend and create the colors that you see here. If I can pull up this website. Oh, I don't think it will show you because I'm only recording this certain tab. Okay, maybe I'll try and include some of the pictures in the pod slides after this lesson. Okay, so here in our diagram, you see the aurora over here. Let me get my little pen again. Okay, so here's the aurora borealis, or the northern lights. Yikes, I tried to circle it, but it got a little shaky there. Okay, but this is a thermosphere. All right, now over here, I want you to look in this little column to the left to show you how thick the thermosphere really is. Okay, so I'm going to make little dots in each layer. So down here is the troposphere. Then we have the stratosphere. Here with the shooting stars, we have the mesosphere. And now look at how much space is in the thermosphere. Okay, so much. It goes all the way up. In comparison, this is clearly the most thick layer. However, even though it has the least amount of air. Okay, so thermosphere is the biggest. It's also the hottest. Remember that term therm that I was telling you about, or the root word, I should say. Okay, the last layer is the fifth layer. Some diagrams will include this layer, some won't, but this is what we call the exosphere. And as I mentioned earlier, the easiest way to remember this is that this is the last layer as you're exiting the atmosphere. It's the last one, the exosphere. This is the atmosphere layer that is the farthest away from the Earth. It starts at 300 kilometers and then goes out until the end of the atmosphere. And the characteristic of this layer is this is where satellites orbit, okay? I believe I have a picture of it on this next slide. This would be an example of a satellite, okay? These are machines that we send up into space. They're close enough to Earth to where they're still stuck in the gravitational pull of the Earth. Therefore, they're still orbiting, okay? They don't actually go so far. They just begin to float off. They're still stuck in orbit, so they're going around the Earth. But they're so far away that they're actually in the exosphere. And we use satellites for lots of things. Cell phone satellites is what allows a lot of our cell phones to work. It can help with things like our internet, our GPS in our cars or on our phones. Our government uses satellites even for safety, military, things like that. So any satellites that we send into space will orbit in that exosphere. This is a deep layer as well that contains very little air. Remember, it is the transition layer between the atmosphere and outer space. So it is the outermost layer. So the least amount of air is in the exosphere. Okay. And then once you are outside of the exosphere, you're technically in space. You are no longer in the Earth's atmosphere anymore. Okay. So again, this is just the diagram, the full thing. We have the troposphere here on the bottom, then the stratosphere, the mesosphere, the thermosphere. And like I said, in this diagram, it doesn't show you the exosphere, but it would be up here. I'm just going to put EX for short. Okay. So I believe that is the end of our notes for today. And you are also going to complete a summary. That's your assignment for today. A 1-sentence summary giving me an overall view of this lesson. Okay, so don't spend your whole summary talking about one layer. Don't tell me, the mesosphere is the layer where meteors burn up. Okay, well, you gave me a detail that we talked about inside of this lesson, but that was not the point of the whole lesson. I didn't spend the entire lesson talking about the mesosphere, right? So try to give me a broader view of what we have studied in this lesson and why it was important to include it with our unit. Okay. And then after that, make sure you study your notes for the quiz on Monday. I believe I have that in your newsletter as well. And then on Monday, we'll put all of this into our own diagram to include in your notes. And that should be it. Otherwise, I'll see you guys Monday.